more difficult could it be? Well, the last one is easy because we could identify the radical on the bottom and just get rid of the whole thing right away. But now, we've decided that we've got a 3 minus 2 root 6 on the bottom. So if I just multiply this whole thing by root 6, I'm going to have a root 6 still because it's going to be 3 root 6 on the bottom. So now I have to figure out how to get rid of this without adding a radical over here. And this is where that fabulous difference of perfect squares comes in again, because I'm going to make this the middle term, and the middle term disappears when I have a difference of perfect squares. So what I'm going to do here is multiply this by the same thing, top and bottom, the way I always will if I'm trying to keep a fraction the same value. And I'm going to create a difference of perfect squares on the bottom, which is going to get rid of that term right there. Watch this. We go 3 plus 2 root 6. I've got to have the signs opposite, numbers the same. Difference of perfect squares. Awesome stuff. And obviously, if I want to keep the value the same, I have to do the same thing to the top. So I'm going to have to multiply everything on the top here by that same value. So now, you're looking at this going, wait a minute, you have to FOIL the top and FOIL the bottom. Yes, that sucks. It's going to take a bit. But we've been practicing, so we should be good. So what we're going to do there is I'm going to go 3 root 2 minus 6 times 3 plus 2 root 6 on the top. And I could write this out that way, or I could cheat. I guess for this one I'll write it out. Minus 2 root 6, 3 plus 2 root 6. And remember that I don't have to FOIL this because I can just go this squared minus this squared, right? So we've at least got that bit helping us out. So we're going to FOIL the top. So we're going to have 3 root 2 times 3 is 9 root 2. And 3 root 2 times 2 root 6 is going to give us, it's a positive 6 root 12. Uh-oh, there's that root 12. I have to muck with that a little bit later. Now I'm going to go middle terms. Negative 6 times 3 just gives me negative 18. And my last term would be negative 6 times positive, so that's a negative 12 root 6 on that one. So make my line, and I'm just too lazy to do it long. I would go 3 times 3 is 9, and then I would go 3 times 2 root 6 is no one cares because it's positive. It's exactly the same as this is going to be a negative. Those two are going to cancel out, so I'm going to end up with just minus 2 root 6 squared. So I'm going to go, here, we'll do this. 3 times 3 is 9, minus 2 root 6 times 2 root 6 is 4 times 6, because root 6 times root 6 is 6. So I can do the bottom first, actually. It's probably easier. We know that this is 24. 9 minus 24, same as negative minus 24 minus 9, so I get minus 15 on the bottom. That's done. I'm going to look up here and ask myself if there's anything I can simplify, and it doesn't look like there is. But if I look at the 12, I know that the 12 is actually 4 times 3, so I'm going to take that 2 out of there that I would have solved before. So I will end up with 9 root 2 plus 12 root 3, because I solved out the square root of 4, minus 18 minus 12 root 6. So then I can check and see, no, I don't have any other common things. However, these numbers are all really big, so I want to ask, is there a common factor? 9, 12, 18, 12, and 15. Yeah, 3. So I'm going to rewrite this entire thing. Woohoo! I think maybe over here, because I think I'm running out of space, I'm going to take a 3 out of everything. So it's going to be 3 root 2 plus 4 root 3 minus 6 minus 4 root 6 all over negative 5. Doesn't seem like there's anything more we can do. Your book might put these ones in a slightly different order, but it doesn't matter as long as they're all there and they all have the correct negatives and positives in front of them. Should be fine.